In this problem, we've been looking at this capacitor, which has been charged up by a battery. We're going to ask ourselves what the initial charge of that would be. And we could say that Q would be equal to CV for that particular capacitor. We'll call that V naught, Q naught. Then we're going to attach this to another capacitor down over here, just like that, which is going to have C over 2 capacitance. Now, we are going to have a final charge, which is going to be QF, equal to well, this the final capacitance together times of VF. And from here we know two things. First, we know that charge is conserved when we do this because, well, like, where's the charge going to go? So we actually know that Q naught is equal to QF, so that tells us that these two things are actually also equal to CV naught is equal to CEQ VF. Well, what's CEQ? CEQ is going to be equal to the addition of those two. So C plus C over 2, which is going to be equal to 3C over 2. And so now we can plug that into this equation. We'll get CV naught is equal to 3C over 2 times VF. The C should cancel, and we'll get that the VF is going to be equal to 2/3 the initial potential. And that's going to be our second answer. So we already got the first one, which is here, and the second one, which is here. This is the initial, this is the final, and that's the voltage. Now for the U, it's not too bad. We'll just go U equals, we could try CV squared over 2. And sure, if that's the case, then we can go, this is the final U. So we're going to use the final capacitor, which is supposed to be 3C over 2. And then we're also going to use the V, this would be VF squared. So we'll do 4 V naught squared over 9. Divide that by 2. Leads us to 12 C V naught squared over 36. Which is just going to be, I think, 1/3 C V naught squared over 3. That's going to be UF. That's for number 3. Then we'll find the potential energy loss. So the initial U is, so that's UF, then the initial U is going to be equal to CV naught squared over 2. And so if we just go UF minus U naught, CV naught squared over 3 minus CV naught squared over 2, do the little math and stuff, we'll find it's -1/6 CV naught squared. That's going to be the potential energy loss. And then where did the energy go? Well, when we connected these wires, turns out that these wires happen to have like a little bit of resistance to them or something. And well, yeah, so when the energy goes through there, it is lost in thermal energy, thermal heat, thermal radiation, due to the resistance of the wires. And that's essentially what happens. Interesting.